like x plus 3 times the 2x plus 7 or something. Okay? So binomial times one, binomial, we know that we have to FOIL. Because we have to use the distributive property twice. We have to take everything times x and everything times 3. And that's it. Okay, so today we're talking about special types. There's special things that happen when you have different types of polynomials or binomials. It's a word for binomials. First one we're going to talk about is the square of a sum. This is why you use the FOIL method to find the product of two binomials. Some have a specific pattern. So one of them is the square of a sum. So in this case, we're saying, like when we're talking about, to FOIL something when everything is squared on the outside, this means squared means to take it times itself, right? So if I have something like a plus b squared, this really means take it times itself. But instead of having to go through FOIL, which you could, I know it always is going to follow a pattern. So I know if you're going to take something times itself, a binomial times itself, it's always going to follow this pattern, where all I have to do is square the first term, take 2 times the 2 terms, get the middle term, and then I would take this last term and square. It's always going to follow this pattern. Like, let's look at this example. If we were going to FOIL it, I would write it like this. Take it times itself. Okay, let's FOIL. What are we going to do first? Would get us 16y squared. 16y squared. Then what would we do?
4y times 5.
4y times 5 gets us
21.
Then we would do
5 times 4y and 21.
And then
5 times 5
would be 5. Then we would put these together. So we would have 40y is 25. Okay, this is what we would get when we FOIL it. That's a valid thing. You could do that. But I know it's going to follow just a pattern. All I have to do, since I'm taking it times itself, is square this first term. Well, what's 4y times 4y? 16y squared. And then I'm going to take 2 times. So I'm going to say 4y times 5 gets us 20y times 2, 40y. And then I would just take 5 times itself. 5 squared is 5. Oh my goodness, look at that. That was the answer. And you didn't have to do all that work.
How would you do the 41?
So I'm going to take the 2 numbers times itself, or times each other. So 4 times 5 is 21, times 2, 41.
What if you have like 3 numbers, like a plus b plus c squared?
Then it's not going to follow this pattern.
So okay, so square, and then multiply, and then times 2, and then you double lots.
Yep, square lots. Yep, so let's see if we can do our pattern on B. So, pattern says, when I'm taking a binomial times itself, or squaring it, I'm going to square this first one. So what's 8c times 8c?
64.
64 what? C squared, so 8c times c, right? Okay, then what's the next thing in our pattern? Okay, multiply them together. So what is 8 times 3? 24 CD, right? Times 2.
40.
So 48 CD. And then we have 2. Square this last one. What's 3D times 3D? 90 squared. Okay, if you're not sure of yourself, we can always go back and we can FOIL it. It's just a little bit more work. So that would mean I'm going to take it times itself. So I would go 8c times 8c gets us 64c squared. And then we would do the outside, which would get us 24d inside, 24d, and then last, 90 squared. Put those together, same thing. Is that cool how that works? You don't have to do so much work. Okay, so that would be the sum of, a square of a sum. Square of a sum, because sum means we're adding those 2 terms. If I'm taking the square of a difference where I'm subtracting the two terms, it's the same idea. Same idea. The only thing that's different is that I would be subtracting the middle term. Okay, so let's look at this one. Let's first go by FOIL. So I have 6p minus 1 times itself, 6p minus 1. If we were going to FOIL it, we would go 6p times 6p. Yep, 36p squared. Then we would go minus 6p minus 6p. And then what's a negative times a negative? Positive 1. And then we would put these together. And what would we get? Okay, so if we FOILed it, this is what we get. If we follow the pattern, it's the same exact idea as what we just did. So we're going to square this first term. What's 6p squared?
6p squared.
36p squared. And then I'm going to multiply the two numbers. What's 6p times negative 1?
Negative 6p.
Times 2 gets us.
Negative 6p.
Okay, and then I would take this last one squared. What's negative 1 times negative 1? 1. Plus 1. And again, same answer. Just the only thing that's different is that this middle term is subtracted. This last term will always be added. Because negative times negative is always going to be positive. Okay, does this make sense? Okay, if we were to do B using a pattern, what would we do?
Square the pattern.
Okay, what would we get when we square 5 into the 3? Nope,
25 times 26 minus plus 20
into the 30. Yep. And then
plus 4 and square.
I think it's easiest to use the pattern. If this pattern then confuses you and you want to go by FOIL, you should do that because you're going to come up with the same answer. But I think it's easiest to do that. Questions so far? Do you want to do another example? Okay, switching of the papers to the next page. All right. Punnett squares. Have you guys talked about Punnett squares in class again? No. You should have an 8th grade thing in science. I remember using it, right? Okay, Punnett squares have to do with genes and dominant genes and recessive genes. So this Punnett square shows the possible gene combinations of the cross between two pea plants. So each plant has to belong a dominant gene T, big T, for tallness, and a recessive gene, little t, for shortness. Okay, it says, show how the combinations can be modeled by the square of a binomial, and then determine what percent of the offspring will be pure tall, hybrid tall, and pure short. Alright, so if we're talking about genes and recessive and dominant genes, like, what's one of them? Like being able to roll your tongue. Okay, are you able to do that? Some people aren't. Some people can't, like I can. Okay? All of you? Can you all roll your tongue? Okay.
No.
James can't roll his tongue.
Try it, James.
I can't.
Just try it.
Okay, so James has a recessive gene. The dominant gene is that people can roll their tongues. Okay, so your parents are going to pass that on to you. So I'm assuming, James, that both of your parents will not be able to roll their tongue because the dominant genes of rolling tongues will be passed on. They're going to take over above the non-rolling tongue gene. Does this make sense? Okay, so the only way that you will not be able to roll your tongue is if your parents both have a gene where you cannot roll their tongue. Okay, if your parents have, at least one parent has a gene that you can roll your tongue, you're going to get rolling your tongue. Does this make sense, kind of? Okay, so in this case with these pea plants, the dominant gene is the tall. Notice that both of them have the gene for tall and for short. Tall and short. Okay, both of them have those genes. So in this case, we could have tall, tall. You could have tall, short, 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 short. Notice that if I have a big T, that means that I have a 3 out of 4 chance of getting a tall pea plant. There's only one time where it's going to short one. Follow me? Okay, so then it asks us to show how the combinations can be modeled by the square of a binomial. So binomial is two pieces, right? We're going to have a big T, and we're going to have a little t, for short. Since I'm taking that combination of genes times itself over here, I can either write it with a square, or if we say this the same as big T, plus little t, times big T plus little t. So I'm taking it times itself. Follow me? Okay? So then I would say, all right, let's use our pattern. What are we going to get?
T squared
Big T squared
plus 2 big T little t plus T squared little t squared.
T squared. Yep. And I already gave away the last one. So determine what percent of the offspring will be pure tall, hybrid tall, and pure short. So I just didn't quite do it all, right? So out of the Punnett square, looking at the Punnett square, how many chances do they have to be pure tall?
3.
1.
Pure tall is going to be
Oh, 1.
one out of
4.
4. This would be 25. Pure big T. Be 1 out of 4. Or I guess it says as a percent. So this would be a 25% chance. Okay. If it's going to be a hybrid,
50.
it'd be 50 because it's a 2 out of 4 chance. So 50% chance. And if it's going to be a pure short, there's only a 25 because there's only a 1 out of 4 chance. So in order for it to be pure short, it's only 1 out of 4, but tall, definitely much better chance because it's going to be a 75% chance it's going to be a tall. Questions on that? Okay. Last pattern we're going to talk about is the product of the sum and a difference. Product of the sum and a difference, meaning I'm going to have these two numbers, the first and the first, the same number, and my last and my last are going to be the same number. The only thing that's different is one is going to be a plus and one is going to be a minus. Okay? When this happens, let's just do this one. Okay, if I was going to pull it. Okay, so first times first, we're going to say,
9 squared.
and then outside gets us,
-6.
and inside,
6.
and last times last. Yep. Okay, what happens?
It cancels out.
It does. It cancels out. These guys are gone because the -6 plus a 6 is 9. So we just end up with 9n squared minus 4. This is our pattern. When I have a plus and a minus, and all the numbers are exactly the same, the middle terms are always going to cancel. Always. So all you have to do is square the first term, square the last term. Okay. That's all right.
Oh,
Yeah. And then it says the resulting product, so our answer, is called the difference of squares. This would be the difference of squares because 9n squared is a perfect square because I know 9n squared gets us, or 3n squared gets us 9 squared, and I know what squared gets us 4 will be equal to 2. So both numbers are always going to be perfect squares. All right, let's try B. Since I know they're exactly the same, the only thing that's different is our signs. You know the middle term, they're going to cancel out. All we have to think is, well, what's the first term squared?
22b squared.
Okay, middle terms cancel out. So it's going to be minus, what's 8w squared squared?
64w4.
There you go. And again, it's a difference of squares because I know this is going to be 11b squared minus 8w squared.
So basically, you just totally ignore the second one and you just go to one and just
Right. Because, or you can think all we're really doing is first first times first, and last times last, because the middle terms cancel. Questions on things? Okay. Homework is in the book.